Let us look at proposition number 10 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please, beginning from a unit, are in continued proportion, and the number after the unit is not a square, then neither is any other number except the third from the unit and all those which leave out 1. And if the number after the unit is not cubic, then neither is any other cubic except the fourth and all those which leave out 2. Okay, let's see how we can prove this. Given unit A, B, C, D, E in continued proportion, which basically means starting from the unit, such that A is not a square. In our previous proposition, we have already shown that the third, that is B, and every alternate number after B is a square. So B is a square, D is a square, F is a square. We have to show that C is not a square and E is not a square. So let's take C. If possible, let C be square. So, which means what? B is to C is equal to square is to square. Why? Because B is a square here and we have assumed that C is a square. So their ratio will be equal to square is to square. But because it is in continued proportion, we can also say B is to C is equal to A is to, which means since B is to C is equal to square is to square, we can say A is to B is equal to square is to square. That means A and B are similar plane numbers. Plane numbers means what? That they are products of two numbers. Similar means that their sides, their corresponding sides are in proportion. Okay, since B is square, that means A is also a square. And remember, is A square? No, it is given that A is not a square. So we have arrived at a contradiction. So that means that our assumption was wrong, and our assumption was that C is a square. So because of the contradiction, we can say C is not a square. Similarly, we can prove for E as well. Same procedure. But now let's look at cube, the second part of the proposition. Given unit A, B, C, D, E in continued proportion starting from the unit such that A is not a cube. Based on the previous proposition, we have seen that the fourth, that is C, and skipping every two numbers after C is a cube. So C is a cube, skip 2, F is a cube, and if we had more numbers, skip 2, the next one will be a cube. So we have already seen this. But what this proposition is saying is that the remaining numbers will be not cubes because A is not a cube. So let's see for D. So if possible, let D be a cube. Now C is to D equal to B is to C because this is in continued proportion. Now B is to C is equal to cube is to cube. How did this come? Because C is a cube and we have assumed that D is a cube. So C is to D is equal to cube is to cube. But C is to D is equal to B is to C. So which means B is to C is also in the ratio of cube is to cube. Since C is a cube, because of this proportionality, B is also a cube. Now, we also know that unit is to A is equal to A is to B. So which means unit measures A based on the units in A, and A measures B based on the units in A, which means B is equal to A times A. So if a number multiplied by itself makes a cubic number, then it itself is a cube. Again, we have shown this previous. So which means A is a cube. Okay, now if you look at it, We have arrived at A is a cube. But is that true? We are given that A is not a cube. So which means we have reached a contradiction, which means our assumption was wrong. And the assumption was what? If possible, let D be a cube. So our assumption is wrong, which means D is not a cube. Similarly, we can show that E is also not a cube. With respect to squares, no numbers except B and every alternate number from B is a square if A is not a square. And with respect to cubes, similarly, no other numbers except C and skipping every two numbers after C is a cube if A is not a cube. So that is proposition number 10 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.